Hello guys, welcome to Pantech Solutions, and I'm warmly welcome you for the series Raspberry Pi Masterclass Day 9. So in this session we are going to see speed control of DC motor. So we are not going to only learn about speed control DC motor directly, like source code and all. So before that we are going to learn like how to study a data sheet. So those kind of little tips about mainly about SPI protocol. Okay, so about and then MCP3008 and about ADC. Okay, so I hope you like the session. Okay, so before going on to the session, same as like there is an announcement. So attendance link will be available around 6:30 p.m. So once the session is completed, start filling up the attendance form. Until then, don't rush for the attendance form. Okay, so good evening guys. Good evening Sandeep Kumar, Siba Prasad, and Bindu and Sumit, um, Rakesh and Gokul. Good evening guys. So we'll move on to the session. So first of all, we are going to see about analog to digital converter. So those things we have already seen on the previous session, but here we are going to see a little bit additional information about it, and serial peripheral interface, that is SPI protocol, and analog sensor interface. Like we are going to interface kind of potentiometer to adjust the speed of the motor, and finally of course we are going to have a discussion and Q&A. Okay, so that's it. So prerequisite for this course, so actually here we have used additional hardware such as MCP3008, which is means like external analog to digital converter, I hope we know, and breadboard. So breadboard like for basic operation, and other than that so breadboard is added 2 times. Okay, no problem. So 10K trim pot, that is nothing but a potentiometer, and 220 ohm resistor. Okay, so and then 2N double two transistor, and then one motor, and then 9-volt battery, and that's it. Okay, so please skip the last two components which I have added. Okay, so that's all the like prerequisite. So here before going on to the session, I would like to say like about kind of resistor and then transistor, so which we have used here. Okay, so first of all, I would like to say about like trim pot. So I hope you know about the trim pot, right? So like we used to adjust the speed of the fan. Like we used to have it'll be like zero means so fan should be in off condition. So if you are increasing linearly, so the speed of the fan going to be increased, right? So that is kind of a basic potentiometer. Okay, so that's the thing here which we are going to use it for to adjust the speed of the normal DC motor. Okay, so and then you may ask, so what is the purpose of using 220 ohm resistor and 2N2222 transistor and those things, and so there are a lot of participants may know about like resistor and then transistor and all. So if you know the answer, so my question is what is resistor? So just put one word answer, sorry, one line sentence answer and then transistor. Okay, what is the answer? So if you know, you just tell your answers in the live chat so that other will know. So and anyhow I'll tell the answer also. Okay, so what is the purpose of resistor and what is the purpose of transistor normally? Okay, and later on I'll tell you like what is the purpose which serves in this circuit, okay, which we are going to work on. Okay, so that's the main thing. Okay, so I hope you got it. So first of all, analog to digital converter, I hope we have already seen, and I'm telling you again. So anyhow, don't skip any session. Still, we have seen this topic again. We have already saw that topic and all. Okay, don't think like that, because on each and every session we're going to give a little bit like different information. Okay, so here we have analog to digital converter. So analog, I hope you know about little, right? That is kind of sinusoidal, like for stop, that is positive, and then zero, and then again negative, right? So it is kind of sinusoidal. Okay, so on that sinusoidal, so that will be like a centralized origin. So on pulse, and then zero, and then like negative, so and then on and then negative. Okay, so we are getting the answers like resistor is used to oppose or restrict the flow of current, that is by Apeksha Kasat. It's great answer, thank you so much for your answer. And Abhishek Kumar, transistor is used to amplify current. Okay, okay, so let it be, yeah. Like it is kind of switching. Okay, so resistor is going to restrict the flow of current through the circuit, and transistor is kind of acting like a switch. Okay, so that's the main purpose of using transistor and then resistor. So later on we'll see the main purpose in the circuit. Okay, so now we are seeing about ADC. So analog is already there, right? So that sinusoidal wave which is represented in the first picture. Okay, so and after that it's going to have a three process. So first one is sampling, and then quantization, and then encoding. Okay, So here the sampling is nothing but kind of vertical like divisions. Like for example, there is one sinusoidal wave. So on that sinusoidal wave, how much you can able to sample or divide that kind of x-axis. Okay, that is known as sample, and y-axis is kind of drawing a kind of horizontal, so that it can be like, it will be look like square pulses. So which is represented in the second picture. Okay, on the first picture, the first graph showing the sinusoidal, which is sampled and then quantized. Okay, so like this kind of coding like square pulses. Okay, so from that you can able to get the values that is in the format of digital, like 0101, but it will give you in the, like if let us take a MCP3008. So that is kind of additional analog to digital converter which we are going to interface externally, that going to give the value in the format of hexadecimal. Okay guys, I'm telling you a lot of information which is not present in the PowerPoint. So I hope I suggest you to keep your notes with you. Okay, so that's it. So we are in the MCP3008. What is the output of the MCP3008? That is nothing but a hexadecimal value. Okay, so hexadecimal or sorry, decimal values. Okay, so decimal in the sense like you are getting the values, right, like 434. So like 0 to 1023, which is nothing but a decimal value. Okay, so after we are getting the decimal value, so that is a decimal value. So if you're going to convert that decimal value into the binary, so you can able to see the digital like waveforms. Like for example, like I hope you know about the 8421 logic, right? 8421. So if I want the data like 5 means the logic going to be 0 1 1 again 0. Okay, so 8421, 4 plus 2, that is 6. Okay, if I need a 6, the data number 6 means, so 4 plus 2 going to be 6. So answer is going to be like 0 1 1 and then 0. Okay, if I want, suppose to want a data called 9, so what my pulse going to be, that is going to be on. Okay, so first one is on, and then 0 0 and then again on. Okay, so my digital signal going to be like on and then again off off and then again on. So this means 9, number 9. Okay, so as same as like the data which we are receiving from the ADC, like 0 to 1023. So which means that is nothing but a kind of decimal value which can be also represented as in the kind of binary format to show that is a digital value. Okay, so I hope you got this. So that's the working process of analog to digital converter. Okay, so that is going to be analog. On that it's going to do the sampling, and then here we have this kind of horizontal axis also, to it going to connect like on off on off on off. Okay, so from that it is going to convert it into that kind of decimal value. Okay, so I hope you got this. Okay, so that's it here up to here. Okay, so and then while talking about specific on pulse width modulation, because like fan speed or light brightness, so those things can be only modified with the help of PWM. PWM means pulse width modulation. Here you can able to see the picture. So in this picture clearly it is understandable, right? So for example, let us take a signal. So what is if you are to measure a one signal means, so who you can able to represent it, that is a one signal means, so that is the combination of on and then off. Okay, so like let us take a sinusoidal means, so on and then again off. So this is the one signal. Okay, so like not one signal, that is kind of one part. Same as like on, if I take a digital signal like on and then off. Okay, so this is going to be the one signal. Okay, that is a combination of on and then off. Okay, so that level, so the blue color line which is represented, like small line is represented, so that is known as there. Okay, so on that pulse it should measure the scale or x-axis of the on pulse and then off pulse, that is kind of time, right? So on pulse, so y-axis is going to be the voltage and x-axis is going to be the time. So if the on pulse time is very small, so then it is known as like less duty cycle. Okay, so here in the image 25% duty cycle, which resembles on pulse is smaller when compared to the off pulse. So on pulse is very small when compared to the off pulse. Okay, so here here that it is. Okay, so on is here and then off is very large when compared to the on pulse. So here that duty cycle going to be like 25% duty cycle, whereas if it is a 50% duty cycle, on pulse and then off pulse going to have a same time period. Okay, so for example, let us take one signal or one pulse going to have a 20 ms, that times like 20 millisecond means, so 10 for on and then 10 ms for off means, so that is known as 50% duty. So instead of that 25%, like 25 like on the 20 ms, 5 ms, like 5 millisecond on and 15 millisecond for off means, so that is known as 25% duty cycle. Whereas if the on pulse is larger, so for example 15 ms for on pulse, or like on peak, and then 5 ms for off mean, so that is mean by like 75% is duty cycle. So whenever you are increasing the on pulse width, okay, so we are increasing, or we are more modulating the on pulse width, so from that you are getting the maximum speed. So for example, if it is 100% duty cycle, whereas like completely on, so which means, so your motor or your led going to be like, if you let us take a led means, so it's going to have a more brightness, maximum, like maximum brightness it's going to glow. Whereas let us take a motor means, so it's going to run at the maximum power as much it can. Whereas if you are dropping a 25% duty cycle, it will rotate in a very less speed. Okay, so that it means these kind of pulse width modulation. I hope you got this pulse width modulation. If you got this pulse width modulation, you just put I got it in your live chat. Okay, so that's it about pulse width modulation. And then we are moving on to the MCP 3008. Why we are using, or why we are going for MCP 3008? I hope we already know the reason, because this Raspberry Pi doesn't has inbuilt analog to digital converter, whereas we are going to interface the potentiometer. So potentiometer is a kind of analog. So Raspberry Pi don't have that analog to digital converter. So that what we are going to do is, we are going to add, or we are going to interface external analog to digital converter with the help of this IC integrated circuit, that is MCP3008. While seeing the specification of this MCP3008 is, this is going to be 8 channel. I hope you have your notes. So this MCP3008 going to be a like 8 channel, and it is a 10-bit ADC. Okay, so that's about the basic thing. Okay, so I hope you got this. Okay, so 8 channel in the sense, left side CH0, CH1, CH2, CH3, there are up to like CH0 to CH7. So which means 8 analog sensor you can connect from the left side. On the right side, you're going to have some kind of control pins. So on the control pins, we have the old VCC as well as ground. Other than that, we are going to have a 4 control pins, because this MCP3008 IC going to use the protocol such as SPI. Okay, that is a serial peripheral interface. Okay, on the right side picture, we are seeing the protocol image, like it's going to have MOSI, that is master out slave in, and MISO master in slave out, and SCLK, that is mean clock. And then here we have the chip select. Okay, here normally there is a 4 pins, so chip select going to be like, it going to be connected with some other components. So for example, here it is not required for more number of channel. Here only one channel is required. So for example, here I'm going to connect like only potentiometer with the MCP3008. So only one slave going to be here. Okay, so channel of 0. So I have connected and the like channel 0. Okay, see it's 0 pin. That is the first pin. Okay, so here only we have connected this pin. Okay, so here first of all I'm going to show a little bit timing diagram of SPI protocol. Okay, so for that I'm going to like show you like how to read it. Okay, you just type MCP3008 data sheet. Okay, so that I'm going to show how to do that, and how to download it, and how to check for the data sheet, like seeing the timing diagram and those things. Okay, so here MCP3008 analog to digital converters are here. Okay, you just click it. Okay, so here it is showing like view data sheet. Click that view data sheet, start download. Okay, so here we have the data sheet. Okay, so on the data sheet, so here it is represented as a basic features, like what is the resolution. So 10-bit resolution. So here you may have a question like, what is mean by 10-bit? So we have already discussed, that is like 2 power n, that is mean a resolution. 2 power 10 means, so that value, so that is kind of, it can able to detect like certain voltage level. So for example, if you are using a 3-bit ADC, or like 3-bit resolution ADC, so that that ADC can't able to identify the variation between 1.3 millivolts to 1.4 or 5 millivolts. Okay, so you don't have that kind of sampling rate. So that is mean by real here resolution. Okay, so here we have the pinouts and those things, but I wish to show the SPI protocol timing diagram. Okay, so here I hope we understand that like there are 4 pin chip select lock, and then D in and then D out. Okay, so on that, so first of all it going to send some of the first of all, here there is a chip select. Okay, so here chip select means first of all we need to be turn it to be low, that is mean by chip select. So that in the timing diagram, chip select is in the off condition after turning off. So whenever that chip select is turned off, then we are transmitting the clock pulse. Okay, so on the clock pulse, so we are going to pass the clock pulse. So on that clock pulse, so that this is going to be like clock pin going to transmit the clock, or going to pass the clock. Other than that, here we have this D-in pin. So on the D-in pin, first of all, it will be like start bit, and then here we need to mention either it is a single or it kind of differential. Okay, so here of course we are going to use a only single, because on the single channel we can use like multiple functions. So here we are not going to do that. From a single pin we are going to take only one values, so that's why we need to initialize that as a single. And then here we have three parts. So here three parts is kind of like to specify what kind of channel, or what kind of channel or thing which we are going to use. So for example here we have 8 channel, right? So 8 channel in the sense, so if you need a 8 channel means, so like that means like 100, so something like that, that you from that you can able to specify which channel is required for you. Okay, so that's up to here. So other than that, so after one kind of one certain delay, so then it will start transmitting the data. Okay, so here b0 b1 b2, so up to b9, so it's going to be like 10-bit data, which going to give you the values. Okay, so same as like here there is another diagram. So kind of other information such as pin dimension and those things. Okay, so here if you are see here, so here we are getting these values. Okay, so this is the working flow. So whenever, first of all, whenever we are starting it, so first of all chip select should be low, and then we'll transmit 24 clock pulses. Okay, so 24 pulses will be transmitted. On that 24 pulses, first 7 pulses it kind of like continuous normal process. Okay, so like it will be like a basic conversion timing. Okay, so and after that we'll start the start bit on the DIN. After that start pin we need to specify either it is a single or differential, we need to choose that. And after that we need to start like our channel, and it will be like don't care. Other than that, here D out, so on the D out up to the chip select. Okay, so up to the chip select or up to the channel, like okay, so you need to specify the channel, right? So so here we are going to use the eight channels, right? So we need to specify the channels after a channel. So after a one pulse, after two or pulse, and then last final like up to the clock pulse from 17th to 24th. Okay, so on the clock pulse of 17th pulse to 24th pulse, we have start receiving the data from the analog to digital converter IC. Okay, so here I've already told you, so it's going to be like decimal value. So decimal value we need to convert into like kind of binary. So if you are converted into a binary, so then you will get the exact like data in the format of digital. Okay, so from the digital value you can able to identify the kind of voltage. Okay, so here there is a formula, that is like resolution of ADC by system voltage. These things we have already seen, right? So resolution of ADC, so we have this specify like 2 power n, so that means 1023 divided by 5. And here what is mean by 5? So 5 here it means like supply voltage. Here we are going to use only 3.3. So here you can represent like 1023 divided by 3.3. Okay, and then is equal to ADC reading divided by analog voltage measured. So here ADC reading is not known still now, right? So we need to measure the analog voltage. So what we can do, so let us take a 400. Okay, so like for example ADC reading going to be like 400. Okay, so let us take that is a 400, and then 1023 by divided by 3 3.3. Okay, so you just start your calculation. I hope you all have your calculator in your laptop, right? So you are going to tell me the answer. So for example here let us take 1023 divided by 3.3. I hope you have your notebooks, right? So you just please note down. So 1023 divided by 3.3 is equal to you just put like 440. Okay, so anything you can put it from 0 to 1023. Okay, so you just put 403. Okay, so like 403. Okay, just put 403. So you just find out what is the analog voltage measured. Okay, so I'll wait for your answers. You just do the calculation and you just tell me the answers in the live chat. So the question is, first of all, do the calculation like 1023 divided by 3.3. Instead of 5 we are going to load 3.3, because here MCP3008 IC is connected with the help of 3.3 supply, is equal to 1023 divided by 3.3 is equal to 403 divided by X. Okay, so let us take that analog voltage measured is going to be X. You are going to find that X. Here it is reversed. Okay, so here that one is known, but whereas that ADC reading is unknown. But here we know the ADC reading, that is 403, and you just want to find out the answer. Okay, so we are getting the answers. So from Siba Prasad, that is 310. So the first answer by Siba Prasad, it's really great. And Muhammad Rafi and Sandipan Chanda and Vamsi Krishna, he just mentioned with the floating points also 310.6. And Rakesh Malagi and Dimas. So thank you so much, guys. Thank you so much for your response. Okay, so so from that, so before that, I just actually I just forgot it. So here we have the ADC reading, right? So what is the ADC reading here? So that is mean 403. I have already told you. Okay. So here the 403 is going to be, I already told you, that is a decimal value. Okay. So we need to convert it, or like we need to like do the conversion. So for that, you can do the conversions like you can go for like decimal binary. Okay, so like that you can drop and click any online. There are a lot of online converters are here, so you can put like 403. Okay, so and then convert. So this is going to be the like binary number. Okay, so this is the digital value which we are going to got it here. Okay, so that's up to this kind of digital value. Okay, so and if you want to convert into kind of hexadecimal also, you can convert it. Okay, so like again that is 403. Okay, so and then convert. Okay, so that is going to be like 193. Okay, so likewise you can able to do this kind of conversion to get that value in the format of like how it is going to be represented. Okay, so those things can be done, or those things can be calculated with the help of these kind of formulas and those things. Okay, so I hope you got this. So that is kind of analog to digital conversion. So how the pulse or the pulse wave should be represented there. Okay, yeah, we are getting that exact voltage answers also, like 1.3 volt and all. Okay, so that's really great. Okay, so that's up to here. So okay, so I hope you got this. So we are moving on to the kind of real time like hardware implement. So I hope you got this. If you got this, you just put I got this in your live chat. Okay, so I hope you understand the like how like analog is converted into a digital, and what is the format of MCP3008 it going to give. Okay, so like hexadecimal means like decimal. Okay, so that's it. Okay, so here there is a pinout diagram. So before that, you just see this diagram, circuit diagram, which we have connected. So I hope you have already seen kind of like MCP3008 interface with the Raspberry Pi. Actually, we have discussed the two methods. So first method is kind of interfacing the MCP3008 or ADC, like ADC, with the help of the default SPI pin of the Raspberry Pi. So there are inbuilt like SPI pins are already present in the Raspberry Pi. So that is the first method we have seen. And then another method also we have seen, like we can use any GPIO pins to use like SPI kind of interfaces. Okay, so two program we have seen, especially internship participants. Okay, so same thing, like here we have used the inbuilt pins of Raspberry Pi SPI. Okay, so if you see the pin out here, you can able to see the like configuration such as, or like inbuilt commands such as SPI MOSI, SPI MISO, and then SPI clock, and else you can use like chip select or something like that with the help of this GPIO 7 or GPIO 8. Okay, so I hope you got this. These are the four pins which is already like special, like already which is configured especially for SPI protocol. Okay, it is all the inbuilt pin. So whenever you are going to use some kind of library for a certain protocol, okay, it is not only for SPI, so I'm just giving a general tips. So whenever you are going to use certain library for a protocol, please use the inbuilt pin which is certainly configured for a certain protocol. So for example, here it is already configured for I square C, means that is GPIO 2 and then GPIO 3. But if you are going to use the kind of SPI protocol, means that is GPIO 10 for MOSI, and GPIO 9 for MISO, and the GPIO 11 for clock, and on the right side GPIO 7 and GPIO 8 for chip select. Okay, so these are the four pins which is configured especially for SPI protocol. Okay, so whenever you are using a library for a certain protocol, please use the inbuilt or already configured pins of the Raspberry Pi. But if you are going to write the program from the scratch, so then you can able to use different kind of like where whenever what you want, where you want, so you can connect it at different pins. Okay, so that's my little tips. Okay, so that's it. So this is the connection of LED, so where you can able to connect it. So here we have the trim port circuit diagram. Okay, so here in this trim port, so first pin going to be the ground, and then here we are going to have a data pin, second pin going to be the data, and final pin is going to be power. For the power, here we are going to use MCP3008, which is connected with the 3.3 volt, so that you can also connect this this potentiometer with the 3.3 at the power end, and then input voltage, that is kind of, this is a data, so data pin, it should be connected with the channel 0, and ground to be connected with the ground pin of the Raspberry Pi. Okay, so this is the basic connection for LED. Okay, so to adjust the brightness and all, so same as like for motors. But here, so there is a challenge. Okay, so here we are going to see the purpose of using a resistor and then transistor and all. Okay, so let us take an LED. Okay, so will it consume more current or more power? Of course not, right? Because this is kind of a very tiny device which is not going to consume lot much power. So that kind of voltage crossing to going to be like make fault in LED, which is restricted with the help of putting a resistor on series with the LED, right? Other than that, it won't cause any problem, or it doesn't require any kind of more supply. That is exactly right? Because in this LED, so it's going to glow in like 1.5 volt even. Okay, but whenever you are going to go for like motors, so motors also like we require more number of supply to be given to the motors. So that's why what we have used, so we are going to use the 9 volt battery. So if you are giving the 9 volt battery with the motor, and from the motor if you take the pin out to the Raspberry Pi, definitely that pin going to be get fault in the Raspberry Pi, so Raspberry Pi may get burnt out even. Okay, so because that Raspberry Pi is going to like working like maximum of 5 volt. Okay, so it won't support like 9 volt, so you can't give that kind of connection. Okay, so here so let us take an assumption. So first of all, Raspberry Pi is going to work with 5 volt or 3.3. Okay, so here 5.5 volt is here. Let us assume data pin, in the data pin of the motor we need to pass like we are going to have a 5 volt here, but whereas motor going to have a like kind of 9 volt. Okay, so we are going to power the motor with the 9 volt. Okay, so here that isolation should be there, like Raspberry Pi should not connect with the 9 volt, but motor should rotate with the 9 volt, and the motor is also connected with the Raspberry Pi. So there is an interconnection to make an isolation, to have a switching between 5 volt level to the 9 volt level to the motor. So that's why here we are going to use a transistor. Okay, and other than that, here we have dropped one diode across this motor to avoid that like back EMF. So I hope you understand about the back EMF, right? So there is a magnet, and intermediate we have our armature or rotating kind of thing. Whenever it is crossing that field, so whenever that it is crossing the magnetic field, it will also produce the back EMF on the wire. So on that, whenever it is giving the back EMF, it may get get corrupt in your Raspberry Pi. So that's why, to avoid that kind of back current flow, so we are going to put a diode, because diode is a kind of, it going to allow a positive current on one direction, and in this opposite direction it going to allow only the negative, not a positive supply. Okay, so from the anode to cathode it going to allow like positive, not a negative. So here in this only positive is possible. If you want to pass the negative, so only this way is possible, not this way. Okay, so this is kind of restricting the like flow of back EMF which is produced by the motor. Okay, so that is the first purpose of diode. And transistor is kind of switching to acts like kind of switching between like 5 volt input to the 9 volt which is given in the battery. And then so we are going to use kind of resistor. So what is the purpose of using resistor here? Because whenever your battery is already here, so due to the motor's rotation, due to the motor's requirement, it may consume a power, or sorry, it may consume a more current based on the load. So if I'm holding that motor with my hand, so it may consume lot of loads. So whenever it is having, or it is required more number of load, so transistor may require that kind of current capability. So on the time, so it should not take more load from the Raspberry Pi. Like Raspberry Pi can't supply that much current. So that's why we are just putting one resistor to the base of the transistor. Okay, so I hope you know about the transistor, like base, emitter, and then collector is there. Okay, so that's the connection which we have given here. Okay, so I hope you understand the circuit. And after that MCP3008, of course we are going to give the basic circuit connection same as like before. And we have put one trim port driver, that is a potentiometer, which is connected with ground, and then data. So data is channel number 0. Okay, so MCP3008 with the channel number 0. This is kind of purple wire, and red going to be like supply. Okay, so there is a 3.3 volt. Okay, so we have just used supply called 3.3 volt, and then ground to activate the motor. So motor data pin is given to the 26th pin of the Raspberry Pi. Okay, so I hope you got this. If you understand it, you just put I understand in your live chat, so that I'll have so that I'll understand that you understand. Okay, so that's it. I up to the connection. I hope you understand the connection. Okay, so the circuit diagram is also given in the presentation. If you are an YouTube participant, please take a snap of it. Okay, so that it will be helpful. So before that, we'll go for the program. Same as like the circuit which is here. So I have already given those kind of connection. It looks clumsy, right? But it is going to be like very easy just to see the circuit diagram which is given in the presentation. Okay, so here first of all from the Raspberry Pi, so here MCP3008 is here, and transistor, diode, and then resistor on this side. It is not known here. Okay, so and then here we have potentiometer. Okay, so potentiometer is also connected with MCP3008, and for the battery supply here we are going to use HW battery. I hope you've already seen these kind of batteries. So on that batteries, to connect the batteries with the circuit, I'm just going to connect this battery tag. So from the battery tag I just took two wires to connect as per the circuit diagram, and here we have normal motor. Okay, so here don't bother about the capacitor. Here it is just took from some of the hardware which is already here. Okay, so it is not required at all. You can remove this capacitor. Okay, so and then that's it. Okay, so here we have the battery. Okay, let us give the battery connection. Okay, battery connection is given here. So now still now there is no supply for the motor's PWM. Okay, so that's why it is not rotating. So that we'll start with the programming here. Okay, first of all, Pi in as it is going to be very easy because as I told you again, so I already told that like we are going to learn little bit new whenever we are going to introduce a new topic, or it may be a same topic, but we are going to learn something new. Okay, so on the previous methodology we have used a different methodology, like to interface MCP3008 IC with the Raspberry Pi, where we have implemented scratch based programming. So for example, here if you see the day 4 code, so this is the MCP3008 interface code which is developed from the scratch. So this code can be done for using any GPIO pins of the Raspberry Pi, but whereas here we have used the library based MCP3008 interface, so that you should not use any GPIO pins. You just want to only connect MCP3008 with the Raspberry Pi only for that already selected pins. Okay, so selected pins are already there. That is 4 pins which I have already shown in this GPIO. That is GPIO 10, GPIO 9, GPIO 11, and GPIO 7 only. Okay, so I hope you got this. So that's the connection. Okay, so before that, so this is the connection. So first of all, what we are going to do, we are going to import some kind of library called PWM LED and MCP3008. Okay, which means we are just taking PWM pins. Okay, so like we are going to use a pins. Okay, any pin you can use. Other than that, we just going to initialize. We need to write something, right? So that's why we just initialize a certain pin as a PWM. Okay, because if you are making it to be high means, so it will rotate at maximum speed. If you are making it to low, so it will rotate in very less speed, or it will be like off condition. Okay, either on, or either it will be like on, or it will be in off condition. Okay, so there is no speed variation on that scenario. So that's why we are going to take a certain pin as a PWM. So we just imported the library, and import time is here, so which I hope you know what is the purpose of using time. And then a pot, so we have used another pin name, that is a pot is equal to MCP3008 of 0. So I hope you know what this 0 means. So what is mean by 0 here, please put your answers in the live chat. Okay, so and then LED is equal to PWM LED of 26. So here, which means 26th pin we have just configured for kind of PWM. Okay, so 26th pin is here. Okay, so pin diagram, yeah, in the left side above the ground pin, that is a GPIO 26. Okay, this is the pin which we have used here. Okay, so where 26th pin, where the motor's data is going to be connected. Okay, So and then while true, so on that while true we are going to get the potentiometer value. Okay, so potentiometer value comma 3, so which means like kind of printing the data. So instead of that you can put like a value is equal to what value. Okay, so here you can pass the variable called value. Okay, so that's it. Okay, so I hope you understand. So this is kind of pot value. We are going to read it and then we are going to specify it. Okay, so and we are getting the answers, right? It's really great. The first answer, that is by right answer, that is Abhishek goes. That's really great. That is channel number, and then Kishan, and then Anmol Agarwal and Sibab press, and then Salim. It's really great. That's the correct answer. That is nothing but a channel. Okay, because here the potentiometer is connected with the 0th channel of MCP3008, which means we are going to use the 0th or first channel in the MCP3008. So that the 0 means. Okay, so here what we are going to read it. So we are going to read the value from the potentiometer with the help of what dot value, and we are going to do the round off because it will be like more number of floating points will be there. So to avoid it, so just we just use like that. And if the pot value is less than 0.002, so which means it is very much less voltage. So whenever it is like very much less voltage, then we have just made like LED value is equal to 0. So that motor will be in off condition, or else if it is else condition, we are going to write the value simply. Okay, so like 1.8 means, so for the 1.8 how much the duty cycle going to be there. So for the duty cycle how much the motor should be rotate, so how much supply it will get, for that supply how it going to rotate. Okay, so finally like pot value is going to print out. Okay, so that's up to here. So I hope you got this. So let us okay, so run the program. So here now you are seeing like 0.0. Okay, so let us hardware to. Okay, so in this hardware now you are seeing 0.0, 0.0. Okay, here we haven't done anything like such as kind of like values, or I haven't like driven the potentiometer. Okay, now I need to accelerate, or now I need to like rotate this accelerometer. So now you are seeing that the value is changing, like now it is like again I'm going to like 0.0. Now you can observe this motor. Okay, and also you can able to hear the sound. 0.0 volt or like 0.0 is passing there. Going to linearly increase that. Now it is rotating in the maximum speed. Okay, where the 9 volt is directly passing to the motor. Okay, again I'm decreasing the speed. Can able to see it. Okay, so with the help of that you can able to do like both a lot of learning. So here in this session what we have learned, we have seen analog to digital converter. For that analog to digital converter we have used MCP3008 IC. So with the help of that MCP3008, since it is using SPI protocol, we have seen that SPI protocol too. And after that which is interfaced with the digital pin. So and then we have learned a certain circuit. So what is the purpose of using transistor, resistor, and then diode for the circuit. Okay, so that is also a general purpose of using these kind of circuit. Okay, so I hope you got this. So this is kind of basic functionality. Okay, instead of motor you can also load LED. So for whenever you are using a LED, it doesn't require this like other connections such as transistor, resistor and the diode, because there it is not required for more supply. So these things not required for LEDs. Okay, so I hope you got this. So that's all about this session. Okay, so we have so before that I would like to say about our like our course, Raspberry Pi masterclass. Because if you are seeing a YouTube, so YouTube going to be like for only like 15-day session, but whereas in the Raspberry Pi it's going to be like 30-day session, where you're going to explore a lot, which includes building your own like a mic and then speaker devices with the Raspberry Pi, and how to I'm going to give a little bit idea about like how to design an autonomous robot with the help of lidar and then Raspberry Pi and then robot, like automatically mapping your rooms and those things. I'm going to give a little bit idea about it, and as well as to use a kind of hardware accelerators such as like Intel Movides neural compute stick 2. So we are going to learn lot of information other than that the usual YouTube sessions. Okay, so it is really great to be have a connection on internship. Okay, so internship link is given in the description below, the first link, and from today the second batch is starting from today. So soon register as soon as possible, so that you'll get more benefit for based on that kind of like registration batches. Okay, so register as soon as possible, because now it is only available for like 499. So once the 15 days is completed, definitely it will be changed again to 750 maybe. Okay, so so just grab this offer time, register as soon as possible. Okay, so that will be really great. And if you want to know the feedback, you can refer the feedback or comments which is already given in that learn. So if you want to see that, you can please visit learn.pantechsolutions.net, where you can able to go through or go to like to seeing the preview of each and every courses, like artificial intelligence, MATLAB, and Simulink, the brain computer interface, those things. Okay, and discussion we have started now. Like what is the question which we have started on the yesterday, like that is a radio signals. So if you know about the radio signal, you can start your discussion. Okay, so so I'm waiting for your discussion, guys. You can start your discussion about radio frequency, radio signals. Okay. You want program buy ready. If you really want a program, you can get it in learn.pandexsolutions.net. Just visit learn.pandexsolutions.net and register. Only if you registered for internship, then only you'll get access for accessing each and every video tutorials. And after that, you can also download whatever the attachment which you have discussed in this session, which includes like presentation, source code, and library files, and additional bonus source codes, and each and everything you can get only from the kind of like in the internship. Okay, so yeah, again Vishal Panole, it's really great. The first answer always whenever the discussion start. I think he is really taking serious about the discussion. Thank you so much, Vishal. Radio signal appears to be coming from our galaxy, and approx 9-10 year earlier radio signal came from unidentified source, which is still unidentified. Scientists say that aliens want to connect with us. Yeah, it's really great news. Thank you so much for sharing. And Satyanathan, it signal radio waves with some message for aliens. Okay, that's really great, guys. Okay, so it's really great. Okay, so any other answers, guys? Know the answer, you can start. Okay, I'll start my discussion. Okay, so first of all, while talking about the radio signal, not only like from the aliens and all, we are using in here also like establishing Wi-Fi connection or cellular networks. So there are a lot of application which is done with the help of radio signal. Okay, so and also, so while talking about the like kind of aliens and all, so there is a ionosphere which is already present in the layer of our complete earth, right? So I hope you know about ionosphere, right? So we have studied like lithosphere, so ionosphere, so we have studied a lot of layers, right? So on that ionosphere, no, so this is kind of like blockage. So only if the frequency which is greater than 30 megahertz, then only it can able to penetrate through the ionosphere. So for example, if I'm sending some signal, okay, so if I'm sending or if I'm going to project some of the signal to the space, definitely that signal should be like it should be like maximum, or it should be like greater than 30 megahertz. Okay, if it is less than 30 megahertz, then definitely that ionosphere won't allow that 30 megahertz. Instead of like less than 30 megahertz, if I'm going to transmit 20 megahertz towards the space, so that 20 megahertz will hit that ionosphere and it will be returned back, because only above the 30 megahertz, then only it can able to penetrate through the ionosphere. So that is the second information which we want to know about that kind of signals. Okay, so that is kind of general signals, and that kind of signals can be received like AM radio is there, FM radio is there, and radio telescopes are there, and large scale radio telescopes are there, and even a recent telescope is get crashed. I think we have seen in artificial intelligence tech news. I think so, right? I think really it's really great to have a lot of news because we have got a lot of information about like due to with the help of the tech news, right? We have seen we have studied that news also. And while talking about the AM radio, it can able to allow like it can able to receive only 7 megahertz. But whereas if you're going for large scale like radio telescope, it can able to receive more frequency or high frequency. Okay, so that's up to here. And also the recent signal which is received like from Proxima Centauri. So I hope the participants who have attended artificial intelligence masterclass and Arduino masterclass, they may see in this news also, because we have already seen that tech news as the signal which is received from Proxima Centauri, this kind of same kind of yet kind of planet which is very far from our solar system, which we have already seen. Yeah, we are getting the answer like Satyanathan. It is from Arduino masterclass, because I just forgot it where we have seen this news. Okay, thank you Satya. Okay, so I hope you got this little bit information on today, so like to about like radio signals and all, and ionosphere and those things. Okay, so still now we are getting a lot of radio signals. Even Stephen Hawking was also told that aliens are existing, because before he told that black hole is there, on the time it is still theoretical, so there is not much to believe on that. After capturing it is a huge strikeout on the science. Same as like he also told that aliens, but we don't know when we are going to see the aliens on live. Okay, so I hope you got this. So tomorrow's discussion is going to be very interesting. That is going to be like artificial intelligence. So artificial intelligence masters also here in this online live, so they may be very familiar with artificial intelligence, I hope. Okay, so so definitely we'll have the discussion about artificial intelligence tomorrow. Okay, so definitely we are going to discuss with like unknown facts about artificial intelligence or something like that. Okay, so I hope you like this kind of discussions. So tech news of day 4. So I don't know how many of you people have heard about CES. CES kind of like it is like consumer electronic show. In each year they'll conduct this show. If you guys as an engineer or as a kind of hobbyist, so if you missed this kind of CES, that consumer electronic show, you just want to see, okay, you just put it in the YouTube. CES 2020, CES 18, for each and every year they'll conduct the CES. So like they'll introduce lot of new technologies, like new technologies they need to implement, or they just need to provide it in kind of like kind of in a real time like deployments. For example, artificial intelligence based toothbrush. So that toothbrush will do a kind of brushing and all, like they'll have nerve mode or hard mode or soft mode, so you can choose whatever the mode you want. So from that it will do the brushing automatically. Okay, that is kind of artificial intelligence based brush. And some kind of mats are there, so like room mats are there, no? So whenever you are standing on that mat, so it will like it will identify the posture of your standing, so how you are standing there in the mats. Okay, so mattress. Okay, so on the time so from that you are standing posture, so from your mobile phone it will give the information like you are not standing properly, you are balancing in one leg when compared to the other leg. So you need to have equal balance of two legs. So something kind of technology. Okay, so we are getting more towards CES. Okay, so sorry. Okay, so that's about the CES. Just please look for, don't miss out. Okay, so like consumer electronic show 2020, it's really great. Same as like we are expecting 2020 to be great, so that is also you just want to check it out, you just please check it out. Okay, so in YouTube it will be very interesting and very impressive. Okay, and as well as I hope you know about the OnePlus disappeared glass on the camera, right? So they are using some kind of gas based glass. Whenever you are turning on the camera, then only you can able to see the camera on backside. Whenever if you are not using the camera, that part will be like completely black. That is kind of different class, that is also introduced in the CES 2020, so don't miss it. Okay, so please see that kind of shows, and those that you can able to get how the technology is growing, or how the technology in the current century or thing like that. Okay, so I hope you got this. So we are in the end of the session. So Q&A. So I'm waiting for your questions, guys, so you can ask your questions. Okay. So circuit diagram, what is the need for interconnect negative of pi and 9-volt battery in the transistor? Actually, that is kind of like grounding. Okay, so other than that, this ground. Okay, motor driver not required for the motor. Actually, here we are not performing like clockwise rotation or anti-clockwise rotation. So those things here we just going to only rotate. Okay, so that's why here that L293D and that kind of driver serves no purpose. Okay, so that's why we just directly connected. Yeah, Anupam Kumar, that is a one plus McLaren edition. Yeah, exactly right. Vishal Pendley asked, motor dynamo also produce some electricity. Then will there be any change in values? Didn't get your question. So can you ask it clearly? Vishal, Manish Singh, thank you sir for the daily session. Thank you so much, Manish. Guys, I'm waiting for your questions. If you have any questions, you can ask now. A masterclass live. When will it come? Actually, already artificial intelligence masterclass is there. So if you want, you can check it out from here. Like just please visit learn.pantechsolution.net. Okay, so if you want to register for a certain masterclass, you can register by the link given in the description. So in the description, there is like artificial intelligence masterclass link, registration link, and Arduino, and then the MATLAB, and then Simulink, and then Brain Computer Masterclass. Uh, Masterclass link in the description. Please check it out. And don't see price which is this here. Okay, it is not the actual price, but now due to this COVID and all, so we are providing with the very cheapest price ever. Okay, so don't compare the price which is represented here. Okay, please go for the description to know about the price of each and every course. Okay, I think we are in the end of the session, right? So I hope you are doing good. So like to attend the session each and every day, really great. Whenever you are doing certain kind of thing for more than like 21 days, then it will be definitely it will be turned into a habit. So that's why we are providing the internship. Please register for the internship, then have a practice on each and every day. Have one class session so that you'll have that knowledge and you'll make that learning to be habit. So thank you so much for attending this session and this series even. And if you want to know about the course, please visit learn.panicsolutions.net. And if you want to know about kind of project, or if you want to do your final year project, or if you want to know about a certain kind of product, you can visit www.pantechsolutions.net. And quote of this day: the science of today is the technology of tomorrow, by Edward Teller. So it's a really great quote, right? So do the science, learn the science. So that's why we have started the discussion of about the science completely. So whatever will be the engineer of you, like either you are a computer engineer or a mechanical or electrical, but we need to know the basic science of everything going to be science, right? So we need to learn though everything. So that's it. So I hope you are liking this session. And there is our YouTube channel. If you haven't subscribed for the YouTube channel, you just please subscribe to the YouTube channel and share to your friends, and let other students to learn about this course also, because due to this quarantine everyone is going home, so a lot of people are wasting the time. So if you want to share your knowledge or share these kind of courses with your friends, you just please share this course with your friends. And especially with our apart from YouTube, because YouTube video will be deleted after like even if after the days goes on, every videos will be deleted from the YouTube. So the only way is to go for internship, because really it will be very helpful. Okay, so thank you so much for every participant who ever interacted me. Whenever I'm asking a questions to put yes or no, or I'm in, or I like, or I understand. So a lot of people are answering to me in the live chat. So first of all, I will like to give special thanks to that kind of participants. And thank you for participants who have interacted with me as questions. So still now we are getting little questions. So sorry for that, not replying for each and every questions. If you have any questions, you just put your comments in the comments below. And if you have any questions for internship participants, just post your questions in the internship forum. So thank you once again, guys. So it's me, Sanjay. Until then, bye. We'll see you on the tomorrow session.